All right, lesson 8 of unit 6. Here are some relationships that produce graphs that have a repetitive nature. All right, now repetitive nature, what we want to do is we want to go back to our lesson notes from unit 1, and we want to talk about repetitive nature means we have a periodic function. Okay, I've talked about this previously, but a periodic function is a function whose values repeat themselves over a regular interval. Okay, so that regular interval is known as the period. So when they say here, are some relationships that produce graphs that have a repetitive nature, what they're really saying is that these are periodic functions. So for each situation, describe the dependent and independent variable. How does the dependent variable change? What might cause this change? So the dependent variable, okay, the dependent variable is your y value. Your independent variable is your x value. Okay, with the y value is called the dependent variable because it depends on what the x value does. Okay, so in this case, the independent variable in number 1 is time, and the dependent variable is the distance from the starting line. And you can see the graph is kind of a wavy shape, so it repeats itself over a certain number of time. So notice each time it goes through a cycle, it goes about 1.7 miles to the starting line. So it starts at 0 and then goes to about 1.7 miles from the start finish line and then goes back down to 0. And then it goes back up and then it goes back down to 0. Okay, so the distance from the start line goes from 0 to 1.7 miles and back to 0. And back to 0. Okay? And then it repeats itself. Now, how often does it repeat itself? So this would be, I would say, about 1.7 minutes. Okay? And then it repeats itself here, and then it's going to come back down and repeat itself here. So it's going to repeat itself. Every minute and a half, all right, or a little bit more than a minute and a half. Okay, so this cycle repeats itself every 1.7, we'll call it 1.7 to 1.8 minutes. Okay. All right. Now, the next one, what might cause this change? Well, why are they constantly going up and then down? Because they're doing laps around a track. So what might cause this change? Doing laps around the track. Okay. Number 2, this is the graph of the temperature in a city in Australia over 21 days. So notice it does the same up, down, up, down. Now the maximum, unlike in the number 1, the maximum does not stay the same. Notice the maximum is over here, but then it increases up here, and then the maximum is all the way up here. And it's the same thing with the minimum, but it goes up and then it goes down. Let me change the color here. So it goes up and then it goes down at the end of each day. And then it goes up and then it goes down. Okay? And that's about every day. Okay? So the temperature the temperature goes up, reaches a maximum point, and then goes down. Okay? This cycle repeats itself every day. Okay? So there's a high temperature and a low temperature for each day. The important thing to note is, unlike number 1, the max and min points for each day are different. Okay? The max and min points for each day are different. Now, why might this be the case? Well, it would be because there's different seasons, right? So your high temperature in January is going to be different from your high temperature in February or March or April, so on and so forth. But it still has that same general cycle. It goes up, it reaches a high temperature for the day, and then goes down. Goes up, goes down, and it repeats itself every day. Okay? This is the graph of two populations over time. So the red is the population of hare, and the blue is the population of lynx. And you can see they both, again, have the up, down motion. Okay? So let's see. Obviously, the maximum points and the minimum points in population are different. Okay? Each time it repeats itself. But let's see. For the red, okay, for the hare, it goes from about here to here. And notice it's about the same. Okay, repeats itself again here, repeats itself again here. So it repeats itself, about every 15 to 20 years. Okay, it repeats itself about every 15 to 20 years. Now, are they different? Yes, the max and the min points are different. Are the hare and the lynx populations different? Yes, they are. But they both repeat themselves about every 15 to 20 years. Actually, I would say even probably 10 to 15 years. Okay? So the population of hare and lynx both go up, reach a high point, and then come back down. And then come back down. The high and low points are different each time, each cycle, and for each animal. Okay? But the key is both repeat themselves approximately every 10 to 15 years. Okay? So even though the max and the mins are different, just like with the temperature, okay, even though the max and the mins are different, Okay, it still goes up, reaches a rough high point, and then comes down. Okay. Now notice with this one, I kind of changed my answer along the way. The key with this is it wasn't so much getting the exact number correct. The purpose of this activity and the purpose of this lesson is to recognize when we have a periodic function. So when you have a function that increases and then decreases and then increases and then decreases, and it does it over a fairly regular interval, that is known as a periodic function. In the case of number 2 and number 3, okay, it wasn't obvious how often it repeated itself. It wasn't as obvious as, say, number 1 was when we were going around the racetrack. Okay, so again, if you didn't get the exact same numbers that I did, that's fine. The key is recognizing the fact that all of these functions are indeed periodic functions. And that is it for this lesson.